All right, so I'm going to go over the FRQ that was assigned on Thursday on Google Classroom. So we've been given a table of derivative values. Part A says to use a midpoint Riemann sum with 3 subintervals of equal length to approximate the value of f of 6. And all we have to go by is a table. Okay, so we can't take the antiderivative of a function. We can't use area under a curve with area formulas because that would require me to have a graph. So all I can do is approximate using rectangular area. Riemann sum means rectangular area. What the value of the definite integral might be. So the Riemann sum from 0 to 6 of f prime of 6 dx, okay, that's going to approximate some original function value, but what we need to remember is this is just going to tell me how much has increased or how much has decreased, right? If this were velocity, I would think about the antiderivative would just be really the displacement, the change in position. So what we need to think about is this initial value they gave us at x equals 0, we know the value of the function is 20. Okay, so that has to be part of your Riemann sum value for the end here. And then to approximate the value of this definite integral, that's where we're going to use the areas of the rectangles from the Riemann sum. On the video on Thursday, I posted that these would be our 3 equal groups. But I told you to figure out what value to use for a midpoint Riemann sum. In this case, the middle value is the midpoint Riemann sum value that we're going to use for the height of every rectangle. So we've got 20 plus. All right, the first rectangle has a base length of 2 and a height value of 3.5. The next rectangle, right, equal length, should still have a base length of 2. The difference in x from 2 to 4 is 2 times a height of 0.8. And then again, a base length of 2 times a height of 5.8. Okay, so now here, again, you could use your calculator if you need to, because even though this is a non-calculator test, you will be able to use your calculator on the AP exam, but you need to do it quickly. All the problems that are going to be on the AP exam this year are considered to be non-calculator problems, really. There's nothing that you have to have a calculator for. So if I add all of this up plus my initial value of 20, I get 40.2. So I would say that would be a good use of the calculator on this AP exam. Even though it's timed, that helped me actually increase how much time I have left for the other problems. So there's the original function value. Do not forget the initial value.